Hello, this is a session from Sastra University, Tanjavur. I am a second year BTech CSE student, and what I have done is a Python using microcontroller interface and created on a graphical user interface to control it. So uh, let's see it. So what we did is a interface which is using Python tkinter module in a Python. So we have mainly focused on two different ports, analog and digital ports. So we will see on analog ports. So what is analog means we can have the control over the potential range for whatever the throughput is. So now as we have connected LED bulbs, we will talk about luminosity, which is in grayscale range. So it varies from 0 to 255, and in that tkinter module we have implemented two different widgets. One is the entry widget and one button. The entry widget collects the intensity data from the user, so the user should manually type it here, and as a button, when we click on it, just send the data to that microcontroller. So it is useful for controlling speed, luminosity, sound, etc. So now we go to digital ports. Digital ports is like a simple port which has only two states. Either it will be on or off. So we can just control or toggle its state, whether it should be turned on or it should be turned off. So yes, now we focus on how we connect. So we are using on a PySerial library, which is provided in Python itself. This is an approach which offers guaranteed and successful communication, which is also considered as fail-safe approach. So how we communicate? Yeah. So if we want to, for example, this is on methodical indexing technique where we send the data as an integer format, which is then converted to binary and all. So how we pack the data is we are using this. If you want to turn on the bulb which is connected to digital pin 12, then we send the serial data as 12001. So if we divide by 1000, we will get the pin number which pin should be obtained. This is digital pin 12, and if the bulb to be turned on means it should be set as 1. So if we divide by 1000, the remainder part, the modulus we say, right? So the modulus part gives the state whether it should be turned on or off. So if it is 1 means the state 1 is turned on. So how we do it for analog signals is that we have the intensity part. So we will be having that 0 to 255 range. So if we divide by 1000, the remainder will be 251, which is the intensity part. If we divide by 1000, the quotient part, the 10, will be indicating the pin. So now we will see how this interface works. Here we have that section for analog ports. So you can see this analog ports. Now we have entered some random values like 1, 100, 0, 255 and 2000, which is excessive range than the grayscale range. So now if we click that port 11 means if we click the send button, you can see that the light is very dim because the intensity is set to 1. And if we have entered a port 10 as 100 value, the second bulb yeah, the second bulb is turned on to 255 intensity, and the last bulb, even though it is greater than 2000, as we have implemented on if else condition, and we are setting the excessive range as minimum range as 255. So whatever values goes beyond 255, we will get around 255 only. With the same intensity, the last bulb also grows. So now
On the 0 sent to port 9.
yes. So as the intensity is 0 in port 9, the third bulb has not yet started glowing. So it's because the intensity is 0.
Now on running bulb you change to 0.
So the last bulb which we set as 2000, I will set as 20. So you can notice the intensity will be reduced. So you can see that intensity has reduced. So if we need to turn it off, we will set it as 0 and send it back. Now the last bulb has stopped glowing, and similar to last second, so we will send it as 0 so that only one bulb glows.
Okay, like digital pin now.
Yes. So now we have the digital ports. So we have 5 bulbs which has either on or off. So one by one we will go for digital port 4 is clicked on. So S1 and digital port 7, this is the second and third, fourth and fifth. So as I said, the digital ports has two states, so it can be either toggled on or off. So now one by one we will toggle it off. So first one is off, second one off, third one off, fourth one off, fifth one. Yes. So now everything has stopped. Now let us see how the microcontroller sends data and we receive through Python. So here you can see that the data is continuously changing on. The data 1 is the seconds and data 2 is the milliseconds. We get the stream of data using like this values. It is a comma separated value, and we convert it to a string type, and we split it into two datas. So one data is the keeping on updating, and the second data is just the divided by thousands data.